Implement, secure, and manage with VLAN. Having a flat network, performance wouldn't be an issue. But as automation progresses, so has its expanding networks. Like what you're seeing on the screen. If all devices are communicating in one LAN, there must be a big security and performance issue that needs to be solved. Why VLANs are helpful? There are 3 things VLANs can be helpful in a network topology. These are security, performance, and scalability. What's good about VLAN is you have the freedom to grant access to group devices by department or function. I know what you're thinking. You're right. VLAN segment networks to reduce the size of broadcast domain and unnecessary traffic to improve network performance. You can also separate network to isolate different types of traffic and resources for security via access authorization. The natural topology of VLANs offer a key advantage in terms of scalability, ensuring that networks can be expanded in the future without disrupting the physical infrastructure as a whole. But how? In the succeeding slides, we are not just going to talk about how VLANs can be maximized in terms of its functions, but how we can also save ports, since we all know that using more ports means inefficiency. As I mentioned earlier, VLANs allow you to create smaller logical groups for end devices using the same physical structure. There are 2 types of VLANs, tagged and untagged VLANs. So, how can we improve security using a VLAN? We can link the devices and separate their networks to make sure that the devices don't communicate to each other. If you want the device on switch A port 4 to communicate with switch B port 4, or ports 8 from switch A to B, you need to connect each of the ports using a cable. This makes the communication secure but not efficient because you need to connect it to each corresponding port per device. You can use this only if you have a few devices to secure. This is what we refer to as untagged VLANs. To facilitate future network expansion, you can still use your existing physical infrastructure and set it up to divide it into multiple VLANs using IEEE 802.1q. These are known as tagged VLANs, and they allow you to create smaller individual subsection networks. Instead of connecting each base port to secure the line, the tagged VLAN of each switch makes it more convenient to securely communicate without wasting ports. When you connect the port 8 of switch A to port 8 of switch B, each of the port of switch A can communicate with the corresponding port in switch B using tagged VLANs. It means that A's 1 to 4 can communicate with switch B's 1 to 4. Same goes to port 5 to 8 by just using a single cable. Tagged VLANs need to be set up using the VLAN interface. You must enter the VLAN ID so the port would know which device to respond to or which device should come first. In this way, you can secure your network without wasting your ports or each device connected. VLANs position physical LAN into multiple logical networks, which is essential for improving network efficiency, enhancing security, and accommodating the growth of an expanding network without the need for significant changes to the physical infrastructure. It optimizes operations and data protection, making them a fundamental element of modern network architecture for organizations with a constantly expanding network. Beyond expectations, either one can help.